Dear students, today we'll see what do we mean by PN junction. PN junction. Okay. So in easy words, it is just joining of a P-type semiconductor and N-type semiconductor. When you suitably join a P-type semiconductor, say this is P-type, to a N-type semiconductor, this is N-type, it is called as a PN junction. It is suitably joined means it is fabricated in a special way, and this P and N type of semiconductors are joined together. So we know that in P-type semiconductor, holes are majority charge carriers. Holes are majority charge carriers. And in N-type semiconductor, electrons are majority charge carriers. Electrons are majority charge carriers. So these are electrons and these are holes. And the boundary where the both semiconductors meet, this boundary, this interfacing line, this is called as junction. This is called as junction. So as a whole, it is called as PN junction. It is a very important and a basic form of electronics. Now when we join a P-type semiconductor to N-type semiconductor, obviously we know that electrons are negatively charged particles and we assume that holes are positive charge. So because of the difference of concentrations, they start moving. The electrons from N region will start moving to the P region and it will come here and recombine with the hole and neutralizes itself. This electron from N region will come to the P region, it will recombine with the hole and its negative energy will be neutralized. It neutralizes itself. So here the neutralization takes place. So here this electron is going here and neutralizing itself. Similarly, a hole from P region will go to the N region and neutralizes here. Neutralizes here because hole is again a positive charge and electron is negative charge. When they both recombine, neutralization takes place. Okay, now in this process, when the electron goes here and neutralizes, there is a negative ion produced. There is a negative ion produced on the P side. And when a hole goes and recombines with an electron, there is a positive ion produced. So these are ions, these are not movable charges, these are ions which are produced when the neutralization takes place. Then this crossover of electrons to the P side and holes to the N side will take place for some time. And after some time, this crossover will stop. It will saturate because then your diagram will look like this. Your PN junction will look like this. This is your P-type material, this is N-type material. These are holes of P-type. These are electrons of N-type. And because the neutralization process and the production of positive and negative ions, what will happen is at the junction side of P-type, you will have negative ions. You have negative ions. And at the junction side of N side, you will be having positive ions. You will be having positive ions. So a polarity is formed. On one side you are having positive, on one side you are having negative. And this area will be depleted of majority charge carriers. That means there will be no majority charge carriers because holes are here, electrons are here, but in between there are now only ions which are not charge carriers. They are not movable. They are fixed. So this part becomes depleted. That is, there is reduction of majority charge carriers. It is not having any majority charge carriers. So this area is called as depletion layer. Depletion layer. Okay, and because you are having a polarity, positive ion and negative ion, plus minus. So here you are having plus, here you are having minus. That means this area will develop its own electric field. There will be an electric field. So this plus minus will be a electric field which is called as barrier potential. A potential which is opposing the forward bias procedure. Further, what we'll see, this potential will oppose that. Okay, so it is called as a barrier potential. Now this potential, if you take a germanium material for your p-type and n-type, then this potential will be around 0.3 volt. And if you take a silicon material for p-type and n-type, then this potential, a barrier potential, will be 0.7 volt. Okay. Now, whenever you want this combination to conduct, whenever you want this combination to have a flow of current, that time this potential, whatever you are having here, barrier potential in the depletion region, that has to be overcome. Once you overcome that, then only the majority charge carriers from p-type can go to n-type, and the this majority charge carriers of n-type can go to the p-type. That means then crossover can take place. Then it will start conducting. Okay. So here this area is known as your depletion layer. This is automatically formed once your p-type and n-type layers are joined together. When they are joined together, this is automatically formed because of diffusion. And then once this is formed, now this section PN junction. Now this is your PN junction which you are going to use for your applications. Now this PN junction can be taken as your semiconductor diode. Semiconductor diode with a barrier potential. That means if it is made up of germanium, the barrier potential will be 0.3 volt. If it is made up of silicon, the barrier potential will be 0.7 volt. These voltages you have to overcome. If you want to conduct this device, you have to overcome this barrier potentials. And whenever you want to use this device, you can use as this terminal named as anode and this terminal named as cathode. This is how you can use your PN junction. So it is nothing but your semiconductor diode.